Good evening, everyone. So now we are going to discuss about second unit. So here we are going to discuss about digital logic families. Of course, already in our last class we are discussed about AND gate, OR gate, NOT gate. Okay. So today's class now we are going to discuss about logic families. How can we design these AND gate, OR gate, NOT gate? Okay. So in manufacturing, which kind of technologies are used while manufacturing the AND or NOT, NAND, XOR? Okay. So here three kinds of different technologies are there to manufacture the logic gates. First one is TTL. The full form is transistor logic, and while coming to the second one, CMOS, and next one is ECL. So here see, while coming to the first one, classification of digital logic families. So basically the logic families are classified into two types: bipolar logic family, unipolar logic family. So here the bipolar logic family is again classified into two types: saturated as well as non-saturated. So basically the bipolar means here the flow of current is caused due to the both electrons and holes. So that means while coming to these bipolar and unipolar, in bipolar if any IC is manufactured, or basically it is made with transistor logic. So and while coming to the unipolar, it is made with MOS technology. So in bipolar technology, the current conduction is due to both majority as well as minority carriers in the semiconductor devices. While coming to the unipolar, whether it may be cause of holes or it may be cause of electrons, the flow of current must be occurred. And while coming to the classification, see here, initially the bipolar is classified into two types: saturated and non-saturated. So while coming to the saturated, first one is resistor transistor logic, means here the transistor is attached with some resistors. Next, direct coupled transistor logic, here no resistors are used, only transistor is there. And integrated injection logic. Integrated injection means sometimes it is also called I square because of integrated injection, I square logic. And diode transistor logic. In diode transistor logic, it having combination of both diode and transistor to develop the logic. And while coming to the fifth one, high threshold transistor logic. So here the threshold values. Threshold means minimum value when the device is switched on. So threshold means minimum currents or voltages required to switch any device is called threshold. What is meant by threshold? Minimum voltage or currents, those are utilized to switch on the device are called threshold device. So here the high threshold transistor logic means to switch on the device it requires more voltage or current, then the device is called high threshold transistor logic. And while coming to the next one, sixth one, transistor logic. Okay, and sixth one, the transistor logic is again classified into five types. First one is standard transistor logic, and second one is high power transistor logic, low power transistor logic, low power scattering, and scatting. And while coming to the non-saturated, scattered TTL is there and emitter coupled logic is there. Okay, and while coming to the digital logic family unipolar type, so it is made with PMOS, NMOS as well as CMOS. P means P-type metal oxide semiconductor family. In P-type metal oxide semiconductor family, the device must be switched due to the majority carriers of holes. And while coming to the NMOS, N-type metal oxide semiconductor, so here the current conduction is due to the majority charge carriers of electron. And while coming to the CMOS, so see here, in unipolar PN is there and also CMOS is also there. CMOS is also one of the technology. And while coming to the non-saturated, Schottky TTL is there and also emitter coupled logic is there. So this is a brief classification of the digital logic families. Okay. So how many types of logic families are there? Basically, two types are there: One is bipolar and the other one is unipolar. While coming to the bipolar, it is again classified into two types, saturated and non-saturated. Okay. In saturated, it is classified into 6 types, and in TTL is again classified into 5 types. In the main differences between the bipolar and unipolar is, in bipolar transistors are used, in unipolar technique FETs are used, metal oxide semiconductor, whether it may be the P type or it may be the N type. And more too are also there, scattering TTL as well as emitter coupled logic. Okay, while coming to the next, see here. So in logic families, which kind of devices is used? Already I told you, semiconductor materials are used. If any semiconductor material is integrated on a single chip, then that is called IC. So these techniques for manufacturing ICs are bipolar and metal oxide semiconductor. So see here, while coming to the bipolar technology, diodes and transistors are used. Okay, in bipolar already I told you, bi means current conduction or the switching of the device is due to both majority as well as minority charge carriers. So here, while coming to the bipolar families, the diode transistor logic is used, and transistor means it may be the combination of one diode and transistor, or it may be the combination of transistor and transistors, or it may be the combination of the emitter coupled logic. And while coming to the unipolar, MOS families, unipolar means FETs, field effect transistors. Unipolar means the current conduction or the switching of the device is due to only the majority charge carriers, whether it may be the holes or it may be the electrons, not the combination of both, like unipolar. So see here, while coming to the MOS, here two are there, basically P type as well as N type. So here P type and N type. In P type, the switching of the device is mainly due to the majority charge carriers of holes. And while coming to the N channel, here the current conduction or switching of the device is due to the majority charge carriers of electrons. And while coming to the complementary MOSFET, these complementary MOSFETs are the combination of both P channel as well as the N channel. And see here, while comparing with bipolar and unipolar, bipolar technology is fostered for small scale integration chips and for medium scale. But MOS technology is used for large scale integration. Both are accurate, both are useful, but while manufacturing, for the sake of small scale integrated circuits and medium scale. So here small scale means only 10 to 100 components are integrated on the IC. Okay, small scale means 10 to 100 components. Medium scale means 100 to 1000, and while coming to the very large scale, greater than 1000 components are there in integrated circuits, then that is called a large scale integration. So here large scale integration means to make the ICs in large scale integration, any circuit having about 1000 components to 10,000, MOS technology is used. So below 1200 MSI medium scale integration, and below 100 small scale integration. So for small scale and medium, bipolar technologies are used. And see here, digital family is a group of compatible devices, same logic levels and supply voltage, all are having same logic levels. So among all these, first one and bipolar first technique is transistor logic. So see here, while coming to this transistor, the name itself indicates here only two transistors are used. No diode is there and no other element is there. And while comparing with all other, TTL is very fast. At the same time, it is expensive. Expensive and easy to use. Cost is also less because of only transistors are there in the device. Cost is less, that means inexpensive, and it is very easy to use and also fast. And bipolar transistor technology used for MSA means it is used for only medium and small scale. Okay. And while coming to the CMOS, this is a comparison between these two. Complementary metal oxide means this is a complementary means combination of both P channel as well as N channel. And both these are complementary means push pull arrangement. If one is in on condition, the other is must be in off condition. Push and pull. So here push and pull indicate what? If one device is in on means other must be in off condition. So that indicate what? Push pull arrangement. And CMOS devices have very low power. Okay, they are used in large scale devices, that means watches, etc. Costly watches like that. And while coming to the ECL devices, the emitter coupled logic is the fastest of all the logic families. So here the emitter coupled logic is the fastest of all the logic families compared to bipolar and unipolar. ECL is realized using different amplifier. There we are using transistors and FETs, but here we are working with only difference amplifiers. And see here, no dart driven into saturation because of its differential amplifier. It's not a transistor, it is not driven into saturation region. And see here, while coming to the output stage, the high degree of fan out is there, much more outputs are there, but if we producing high outputs, the power dissipation is also very high. Okay, well compared to all other, it is very fast, but here one drawback is that it also requires more power. Power dissipation is very high, means compared to the utilization power, wastage power is much more in the ECL devices. And here fan out is also very high. Fan out indicates the number of outputs produced at the same time is called fan out. And see here, while coming to the specifications of the digital ICs, so here 5 specifications are there: propagation delay, power dissipation, fan in, fan out, as well as noise margin. So these are called what specifications. So while coming to these specifications, so first and foremost one is propagation delay time. So what is meant by propagation and what is meant by delay? So generally what is meant by delay? Wastage of time, or if we want getting anything, it's not after applying input also the output may not be produced. It will take some time. So how much time it will take to produce the outputs after application of the input is called what? Delay time. So here while coming to the propagation delay time, it is the time taken by the output of the gate to change after the input. Delays are same in all, whether it may be digital IC, analog IC, or whatever may be the circuits. Delay time means after application of the input, how much time it will take to produce the output. Here, propagation delay time also time taken for producing the output after application of the input, whatever it may be, both are same. So after application of the input, how much time it will taken by the device to produce the output is called what? Propagation delay time. And while coming to the second one, power dissipation is there. So here power dissipation means amount of power dissipated in an IC. Power means heat. For example, if I would like to apply some amount of voltage to the IC, for example, if I would like to apply 5 volts to the IC, 4 volts must be utilized for the circuit to produce the output and process the input. 1 volt must be produced as in heat in the form of heat. So the production of the voltage in the form of heat is called power dissipation. That power is not utilized, may be converted into the heat. So that is called power dissipation. And while coming to the fan in, maximum number of inputs that can be connected to one particular IC. For example, logic gates are there. More than one inputs are also applied up to infinity, up to n number of inputs. So how many number of max inputs are applied? So what is the maximum? It may be 2, or it may be 3, or it may be 4. So maximum number of inputs that can be connected to an IC is called what? Fan in. And while coming to the fan out, like same, maximum number of outputs that can be connected. Okay, maximum number of inputs can be connected is fan in, and maximum number of outputs can be connected is called fan out. And while coming to the last one, last property, noise margin is there. So that circuit's ability to tolerate the noise signal is noise immunity, and a measure of this is noise margin. So what is meant by noise simply means the ability of the circuit to produce the output without making any disturbance is called noise. If the output is produced with some disturbance, then that is called noise, means the unwanted ripples. If while producing the output any unwanted signals are produced, then that is called what? Noise. So how many number of parameters are there? Basically 5 parameters are there. What are the 5 parameters? Propagation delay is there, fan in is there, fan out is there, power dissipation is there, noise margin is there. Both 5 parameters are having equal priority, all are important. Okay, first one is propagation delay time, power dissipation, fan in as well as fan out. Okay, and see here while coming to the comparison. So now we are discussed about 3 families. One is bipolar, and other one is unipolar, and other one is ECL. So see here one list is there among these 3. Here, one second. Among these 3, here TTL is bipolar and CMOS is unipolar and ECL is very fast. Okay, already we read. And while compared to the comparison, now we are comparing the parameters, not merits and demerits. So 5 parameters are there. First one is propagation delay, fan in, fan out, noise margin, power dissipation. Fan in means how many number of inputs supplied, fan out how many number of outputs supplied. So while coming to these parameters comparison, TTL noise margin is less compared to remaining 0.5 only. But fan outs more than 10 outputs connected, greater than 10. Fan in 12 to 14 inputs are connected in TTL logic. So more than 14 the chip not able to support. And while coming to the propagation delay, 10 nanoseconds means after application of the inputs, the output must be produced after 10 nanoseconds. Very, very short duration. Okay, just like closing of eye, opening of eye, the duration between the eye movements. Okay, so see here in TTL, what is the capacity of number of inputs connected? 12 to 14. And while coming to the number of outputs, greater than 10. Propagation time is very, very less. How much it is? 0.5. Okay, so next while coming to the power dissipation, so here 10 milliwatts, of course it is less, 10 milliwatts. Okay, next while coming to the ECL, okay, emitter collector logic, 0.16 noise margin is there, it is also noise margin less, fan out is more, greater than 10, fan in greater than 10, no minimum, no maximum. And while coming to the propagation delay, less than 3 nanoseconds, very, very fast ECL, less than 3 only, not 10, not less than 3, very fast compared to TTL and CMOS. And power dissipation is also very, very high, 175, so power will be wasted. Okay, but speed, if we want speed we move with ECL, if we want power then we move with TTL. And while coming to the last one, complementary metal oxide semiconductor, here noise is very high, 1.5 times noise is there while producing the outputs. And fan out are both like our ECL greater than 10, and propagation delay is 15 nanoseconds, and the power dissipation is 0.001. Here power dissipation is very, very less. Of course delay is very, very more. After application of input also, the output must be produced after 15 nanoseconds. So compared to ECL, it is very, very high. Of course, compared to TTL, it is somewhat less. But compared to ECL, the device is very slow. ECL is very fast. Means it will produce the outputs in very short duration. But CMOS will take much more time to produce the output comparing to the ECL. Okay, but power dissipation is very less. If we want speed, we move with ECL. If we want to save the power, then we move with the CMOS. Clear? So this is about comparison of logic families. And see here some list is there. These are the different ICs to produce the logic families. So maximum all ICs digital logic families for the NAND, NOT, NOR are available in 74 series. Okay, 74L S00, 74LS01, 74LS02. So this is a 74 series. So here it is 74 series. 74 series will produce 2 input NAND gate, and also it will produce 2 input NAND gate open collector. Collector is not connected to ground, and 74LS02 4 input 4 cross 2 input NOR gate, means available in NAND is there, NOR is there, NAND open collector is there, and also NOT gate is also there. Okay, and while coming to the next one, NOT open collector is also there, NAND open is there, not open is there, NOR open is there, all are available in our 74 series. And see here, in addition to the NAND, 2 input AND gate, 3 input AND gates, 3 input NAND gate, okay, 4 input schema trigger NAND gate, inverter, etc. Everything must be available in this 74 series. Okay, so once check the list. Here in 74 series, high voltage open collector, no operation buffer circuits also there, and schema triggers also there. I think already all of you have an idea about schema triggers. So schema trigger means what? The circuit is able to produce the square wave, then that is called what? Schema trigger. Okay. And the 74 series ICs also produce and NAND, NOR, high voltage with strobo, without strobo, open collector, high voltage open collector, everything is there in our 74 series. See here, more 6 input, 6 output also there, 2 input OR gate is there, 4 by 2 input NOR gate is there, 4 by 2 input NAND gate is there, all are available. Okay, and see here, while coming to the next one, not only NAND, NOR and or means logic gates, here logic circuits also there. Okay, what are the logic circuits here? Decoders, 4 to 10 decoders, 4 inputs are converted into means are passed through the 10 outputs lines. Okay, so and 4 to 10 decoder with high current is also there, and BCD to 7 segment decoders also there. Open collector, lamp tester and leading zero handling is also there, and 74 LS47 BCD to 7 segment decoders also there, open collector, lamp test and leading zero handling is there. So and also 7 segment decoder, lamp test and leading zero handling is also there. So much more, everything is there, decoders are there, 2 input NOR gate, expandable, and after 7000 series, 4000 series, CMOS logic. There are transistor logics, here it is CMOS. So in these 4000 series, everything will be available again here, but here power will be wasted. 4001 2 input NOR is there, 2 input NAND is there, 2 input XOR is there. Okay, 4070 XOR gate is there, OR is there, XOR is there, AND is there, also schema trigger is there. Okay, and while coming to the next one, after 2 input, 3 input gates also there, triple inputs, the name is called, and also dual 4 input gates also there. Okay, so total ICs are available in 7000 series as well as 4000. And see here, the transistor logic is widely used family, so that 7000 series produced AND gate, OR gate, NAND gate, NOR gate, exclusive OR, exclusive NOR, decoder, encoder, everything is available. And TTL is fast and inexpensive to use. And see here, while coming to the TTL and CMOS, both TTL is fast but CMOS is very lesser. So see here, this is the construction of TTL NAND gate. The name itself indicates TTL NAND gate means transistor logic NAND gate. So how many number of transistors are there here? Once see, 2 transistors are there. Okay. So 2 transistors means dual input transistor is one and single input transistor is second one. So here this first transistor is of dual input. Here we would like to connect 2 input. Because of 2 inputs, the term whatever here using here, it is called dual. So dual input means 2 input transistor. That is indicated with letter Q1. How many number of transistors are there? 2 transistors. What are the 2 transistors? Q1 and Q2. So here Q1 is dual input and Q2 is single input. Okay, and these bases, so here these 2 terminals are called emitter and this one is called base and this one is collector. While coming to the Q2, this is base, this is emitter, this is collector. So now once check the connections. Here emitters means inputs are connected to the emitter terminals of Q1 and base of Q1 and collector of Q1 are connected to VCC. Okay, and the collector of Q1 and base of Q2 is connected together. That means output of Q1 is connected to input of Q2. Why? Because output of Q1 is occurred at the collector. So output of Q1 is occurred at collector and input of Q2 is available at base. So output of Q1 is connected to the input of Q2 and emitter of Q2 is connected to the ground. Is it clear? So Q1 having two inputs, that means inputs are connected to the emitter terminals and the output of Q1 is connected to the base of Q2 and the base of Q1 and the collector of Q2 are connected together and it must be given to the supply voltage. And see here, next the emitter of Q2 is connected to ground. So finally here two inputs are there, A and B. After it passing through the transistors Q1 and Q2, the logic produced of Y is AB whole bar. Okay, means the signal must be complemented two times. So see here, already I explained the construction, but once check the slide. So emitter terminals of transistors are the input terminal Q1 emitter. How many number of terminals are there? 2. The collector of Q3 is the output terminal. Means while coming to the once check the slide, he simply described that these two are the input terminals and this is the output terminal. Okay, emitter terminals of Q1 is input and this collector terminal is output. He said like that. And collector Q3 is the output terminal. If one of the input is 0, the corresponding emitter junction is forward biased. If one of the input is 0, the corresponding emitter junction is forward biased. The collector junction is also biased, hence Q1 goes into saturation. See here what he said here. If any of the input is high, if we apply the input to any one terminal also, it must be fall into saturation and it produce the output. Why? Because emitter is the input terminal. If we don't apply any signal, it is in switch off condition or reverse bias condition, no output is produced. Okay, so in this way it works. If one input is 0, the emitter junction is forward biased and output is produced. Collector junction is also biased. Okay, and the base of the Q2 is at low voltage, very low, and Q2 is off gamma. When Q1 is cut off and collector voltage is again increased. Okay, when Q1 is again increased, Q2 goes into the saturation. Simply the two transistors are there. If one transistor and goes into the forward biasing, other must be simply moves into the switch off condition, cut off condition. If first one is in forward bias condition, that means in saturation, second is in cut off region. Why? Because here collector, here emitter base is there, their base collector is there. And first one is in on condition, second one must be is moved into the off. That's why it will give the complementary logic wise. And see here, while coming to the second one, open collector TTL NAND gate logic is there. Okay, so open collector, why it is called open collector means, see here, here emitters of the Q1 is connected to the input and base is connected to next VCC, but here the collector must be Q3 collector is open, the output must be collected across the collector of Q3, but it is opened. Okay, not connected to any other terminal. So here in open collector TTL NAND gate, 3 transistors are used, Q1, Q2 as well as Q3. So in Q1 it is connected to R1 and Q2 is connected to the resistor R2 for the sake of biasing and stabilization, and Q3 is connected to R3. So here these 3 resistors, Q1, Q2, Q3, R1, R2, R3, these 3 R1, R2, R3, these 3 are used for the sake of biasing and stabilization. Biasing means while the outer biasing emitter base is connected in forward bias condition, collector base is in reverse bias condition. Means to provide the stability, here we take the help of resistors R1, R2, R3. Input is connected across here Q1 emitters, 2 input terminal transistor, this one is. and this the emitter terminus, and base collector is connected to Q2, base is connected here. Okay, so in this way this is called what? Open collector. So once see here, a transistor Q2 is used as an emitter follower, means the output is across the emitter is connected to the input of next one, and the output of the Q2 is fed to the input of Q3, means Q1 output is connected to Q2, just simply like a chain. See here once, Q1 is connected to Q2, Q2 is connected to Q3. Output of Q1 is connected to input of Q2, output of Q2 is connected to the input of Q3, simply like a chain reaction. The circuit is similar to that of previous circuit. Okay, and while coming to the next one, see here, one pull-up resistor is used. Why this pull-up resistor is used means to produce the perfect output within duration, and also to produce the perfect output. Here pull-up resistor is used. Okay, and while coming to the next one, see here, one disadvantage is there for the open collector gauge. It is very slow switching speed, means the operation speed is very low, and the pull-up resistance is few kilo ohms. To getting proper output here, we are using one resistor now, so that resistor range is very high. How much it is means some kilo ohms, not ohms. So this is also one disadvantage, and it gives a relatively long time constant when multiplied by the stray. So means the output is produced after more delay. Okay, and in roast class output goes from lows to high, means what? Without application of input also sometimes the output must be produced. Okay, so these are the applications or demerits of the. Okay, and while coming to the next one, TTL NAND gate with totem pole output. Open collector is open, so now it is totem pole output. Totem pole means here the collector is not open. Okay, see here a total 3 resistors along with 1 diode is used. Okay, Q1, Q2, Q3 as it is. Dual input Q1 is there here. Okay, so here dual input Q1 is there, means 2 emitters are used. Input must be connected across these emitters of Q1, and output of Q1 is connected to input of Q2, and output of Q2 across the collector is connected to base of Q3. It is simply like the previous one. Okay, input is connected across Q1, output of Q1 is connected to the input of Q2, and output of Q2 is connected to the input of Q3, and finally we are getting the output is across the emitter of Q3, but not directly. It must be collected between the Q3 and Q4, between the Q3 and Q4. This is only the difference between those two. Okay, see here in this circuit one resistor, the resistor is used na? So the value of that resistor is what? 4 kilo ohms, the first resistor. Okay, this resistor simply acts like 2 input AND gate. How this resistor acts? Simply it acts like a 2 input AND gate. And see here, while coming to this circuit compared to the previous one, except that simply it's like a previous one. And once see the difference between Q3 and Q4, output of Q1 is connected to Q3, Q3 in between Q4 the output is connected because of this diode. So diode is used in between Q3 and Q4 in circuit diagram. So cause of this diode, you can see here, cause of this diode, both outputs are complemented. Okay, if one is high, other is low, like that, cause of that diode. If Q3 output is high, Q4 output is low. If Q4 output is low, Q3 output is high. So in this way it must be switched on and off. And one see here, if A or B is low, the Q1 conducts and base of Q2 is almost 0. But Q2 enters into cutoff region cause of that Q4. Why? Because Q2 is connected to Q4 cutoff region. But Q3 high and it will produce the high output voltage. Simply the logic is here. If Q3 is switched on, Q4 will be off. Q4 is in on condition, Q3 is in off condition. But final output will be collected across the Q3. So when Q3 is conducting, the output impedance is approximately 70 ohms, and when Q4 is saturated, the output impedance is only 12 volts, and hence the output impedance of the totem pole circuit is low. Cause of that only the output is very low. See here, one question is there. TTL is a slow device or fast device? It's a very fast device. Once we check the answer, fast device. Of course, it is utilized for only small scale integrated circuits and also medium scale integrated circuits, but it is not used for large scale integration. Okay, it is utilized for only small scale as well as large scale, but the switching speed is very high. And see here, disadvantages of TTL NAND gate with open collector. It's having a slow switching speed, that is the demerit. See here, already I explained. The use of pull of resistor. What is the use of pull of resistor? Proper power supply operation. To getting proper power supply, here we are taking pull of resistor. And see, use of the diode in totem pole circuit. What is the use of diode in totem pole? One direction passage of current of output stage transistor is there. Okay, diode is there now in totem pole in between Q3 and Q4. So what is the use of diode? They are asking competitive examination. So what is the answer? One direction of passage of current, means the output is coming in only one direction. And see here, while coming to the fourth one, if any digital family group of compatible devices with the same logic levels, okay, and also having same supply, any digital family logic levels and supply voltages, what are the output we are getting and input voltage we are getting, both are same. Okay, supply voltage is equal to that of logic level. And see here, while coming to the next question, which logic family is the fastest logic family? So what they are asking, which logic family is the fastest logic family? So which family is fastest? ECL is the fastest logic family. Okay, which family is the speed? Which one? ECL compared to CMOS and TTL. But only will take the comparison between CMOS and TTL. TTL speed is high. Comparison is take among whole three CMOS, TTL, ECL. ECL is somewhat good compared to all others. And a logic family is fastest because of its operation in saturation region. Okay, and see, in last previous examinations, they are asking repeatedly, draw a TTL NAND gate with totem pole output and draw the TTL NAND gate with open. Of course, classification is also there, parameters also there, but comparing to those 2-3 questions, these TTL NAND gate with totem pole, TTL NAND gate with open collector, these are very important. Okay, and advantages and disadvantages. Okay, so see here, in today's class we are discussed about what various logic families. Okay, and classification of the logic families. Okay, logic families are classified into basically bipolar, okay, unipolar. Bipolar is again classified into saturation, unsaturation, and unipolar is classified into CMOS, NMOS, PMOS. So like that classification is over. And after classification we have discussed about a series of ICs. Okay, our different ICs are produced in 74 series and 4000. And after completion of this, we are deeply discussed about the construction of TTL. So what is the full form of TTL NAND gate? How many number of transistors are there in operation? While coming to the full form, TTL means transistor logic. How many number of transistors are there? 2 transistors. What are the 2 transistors? Q1 and Q2. Okay, and all transistors in the first stage transistors, either it may be TTL NAND gate, or it may be totem pole, or it may be by using a open collector. base transistor, that means first transistor having how many number of inputs? Two inputs are there. Every transistor having two inputs. Okay, and see here, while coming to the comparison between totem pole and open collector. In open collector, the output is collected across the collector by opening. In totem pole, diode is connected between two transistors Q3 and Q4. Okay, so this is about today's class. What are the different logic families? How can we classify? And what are the important series produced by the different companies? And last important topic is parameters. How many number of parameters are there? 5 parameters are there. What are the various parameters? Propagation delay, fan in is there, fan out is there, and also power dissipation is also there. Okay, power dissipation, fan in is there, fan out is there, propagation delay. So what is meant by propagation delay? How much time the device will take to produce the input, to produce the input after application of the input. Okay, how much time the logic gate will take to produce the output after application of the input. And what is meant by fan in? How many number of inputs connected to the device is called fan in. What is meant by fan out? How many number of outputs we are collecting is called the fan out. Okay, this fan in, fan out, propagation delay, power dissipation, amount of heat produced after application of the power supply. So these are the different families. And noise margin is also there, of course. How much noise will be produced while producing the input and output. So this is about today's class. Now I would like to conclude. In tomorrow's class we are discussed about our third unit.